So hopefully you've been thinking about this. You may have even jotted down some ideas about the relationship here. Now hopefully, if our model is right, you understand that there should be a positive relationship between physical capital, human capital, organization, and technical knowledge. But can we zoom in? Let's make, and as I mentioned here, I oftentimes will abbreviate human capital with E. But let's zoom in, and let's zoom in on these individually. We also don't want to forget that there is an implicit factor of production of labor here. Again, we usually abstract away from that because we're talking about per capita GDP. So increasing labor will increase GDP, but holding all else constant, it would not increase GDP per capita. So how do these get turned into output? Well, let's make some simplifying assumptions. First thing is, we can just write these in a mathematical formula, but don't lose your brain because we're doing this. So I'm just going to write it this way. What this says is output is a function of technical knowledge, physical capital, labor, and human capital. Now you'll notice, effective, this is why I put it as E. Human capital enters as a multiplicative of labor. It makes every unit of labor more productive. On its own, it would do nothing. If you had human capital without labor, well, you really can't. And so it ends up being a multiplicative. So all this functional form here is doing is saying the exact same thing we just said earlier, that output is a function of human capital, labor, physical capital, and technical knowledge. Wait, where's organizations? Well, it turns out organizations are important, but as I mentioned a while ago, organizations are difficult to formally model, and so they're not in here. They don't have an abbreviation. Doesn't mean that they're not important. But the way of writing this here is exactly the same thing we've already done. Now, we're going to make some assumptions about this to make our lives easier. Let's start with the simplest setting. So one of the big things that people oftentimes have assumed, and if we go back to when we made a list of what may be causing growth, one of the things on there was mechanization, was in effect how many machines were floating around. And this is a very common idea, is that during the Industrial Revolution, what we did was add more physical capital. And as a result, it was the machines, and in other words, the physical capital, that caused us to grow. So let's start with the simplest setting and sort of go back to what we probably may, if we had a history class that covered the Industrial Revolution, we may remember or vaguely remember, which was that basically the main thing was that machines were driving this. So let's see how just changing physical capital, how far that can get us. So let's start with the assumption that technical knowledge is constant, labor is constant, and human capital is constant. What this means is that the only thing we're going to let change is capital, and we're going to see what impact that has here. In other words, what this would now reduce to, if those other things are staying constant, is Y is a function of machines, or Y is a function of physical capital. Now let's see if we can think about what kind of relationship. Now this needs to be positive. But let's think about what kind of positive relationship. Now, the book is going to throw this at you. Y equals k to the 1/2. Now some of you may remember that this is the same thing as the square root. This is a little tricky. I may need to actually shoot a video here with a whiteboard, because in class what we would have done is say, what can capital be? So you know what? I think I will go ahead and do that here. I will take a break. I will stop this video and start another one with a whiteboard, and then we will come back and revisit this.